Hello guys, this is your host. Welcome back to Access Broadcast. Hey Gemini, welcome to my show Gemini Live with Muguli. So today the topic of discussion will be quantum computing. So let's begin with it.
Okay, sounds like a fascinating topic. So, what exactly about quantum computing do you want to focus on? We could explore the basics, dive into potential applications, or even talk about the challenges scientists are facing in this field. Where would you like to start?
So for the first, I just want to make sure that our audience know what does that quantum computing mean. So can you briefly explain me about some basics, like just briefly explain what is actually quantum computing is?
Okay, here's the thing about quantum computing it's like regular computing, but on steroids. In a normal computer, everything comes down to bits, those tiny pieces of information that are either a 0 or a 1. Quantum computers use something called qubits, which can be both 0 and 1 at the same time. This is called superposition, and it's where all the crazy potential comes from. Because of this, quantum computers can process a ton of information at once. We're talking mind-boggling speeds, compared to even the best supercomputers we have now. Scientists think this could lead to breakthroughs in fields like medicine, materials science, and artificial intelligence. But it's still early days. We're talking theoretical, cutting-edge stuff. There's a ton of research going on, trying to figure out the best way to make these things work.
Okay, so there are multiple scope by which we can use quantum computing in future, right?
Absolutely. Quantum computing has the potential to revolutionize a bunch of different fields. Let's start with medicine. Imagine being able to design new drugs way faster, or even figuring out personalized treatments for individual patients. Quantum computers could crunch through all that biological data in seconds, not years. Then there's materials science. Quantum could help us create new materials with crazy properties. Things that are super strong, super lightweight, or even good at conducting electricity in weird ways. Artificial intelligence is another big one. Quantum could make AI way smarter, way faster, maybe even smart enough to solve some of humanity's biggest problems. Want to hear more examples?
Yeah, please go on.
Alright, here's another one, finance. Quantum computing could make a big difference in things like risk assessment and trading algorithms. Imagine being able to predict market crashes way ahead of time. Or how about developing new financial models that are way more accurate? And finally, let's talk about energy. Scientists think quantum computers could help us design better batteries, more efficient solar panels, and even new ways to generate clean energy.
Oh, like you meant like this quantum computing is our upcoming future technology, right? Like
Absolutely.
it almost gives every potential
Alright, I
like
can
things.
definitely help you with that.
Yes, please continue.
Sorry, I couldn't find anything about February.
No, just
Alright, so
yeah. So like, but that supercomputers are is also like less smarter than.
supercomputers are really powerful, but they
Okay, yeah. Tell me.
absolutely. Here's one way. Quantum computing could change things. Drug discovery. Right now, developing new medicines is a long and expensive process. It can take years of research and testing. But with a quantum computer, scientists could simulate how potential drugs will interact with the human body at a molecular level. This could drastically speed up the whole process. Another area is materials science. Quantum computers could help us design new materials with incredible properties.
Yeah, I
Imagine a
get that
material that's
part,
stronger.
but just tell me about that dark matter, like in quantum technology, how it impacts.
While quantum computing is a fascinating field with a lot of potential, it doesn't really have a direct connection to dark matter. Dark matter is a mysterious substance that we can't directly observe, but we know it exists because of its gravitational effects on visible matter. Quantum computers are amazing for simulating complex systems and could help us understand other mysteries of the universe, but they're not designed to directly detect or interact with things like dark matter.
Okay, like I watched in one of the podcasts of Ranbir, sir, like one guy mentioned about the dark matter while discussing about computing, so that's why I asked you. Never mind.
Cybersecurity. Quantum computing could be a game changer for both defending against cyber attacks and launching them. On one hand, it could help us create unbreakable encryption methods. On the other hand, it could also be used to crack existing encryption, which would be a major problem. Another area is optimization. Quantum computers could help us solve complex optimization problems way faster than classical computers. This could have a huge impact on fields like logistics, supply chain management, and even air traffic control.
So how far we are from that quantum accessing that quantum technology?
We're still in the early stages of quantum computing. Right now, the biggest challenge is just building these machines. We can only make them with a small number of qubits, which limits what they can do. Companies and research labs are making progress, but it'll probably be at least a decade before we have large-scale quantum computers solving real-world problems. Do you want to hear about some of the ways companies are trying to overcome these challenges?
Yeah, please.
Sure, here's the deal. Companies are throwing everything they've got at these challenges. You've got teams focusing on building better qubits. These are the building blocks of quantum computers, and they're super fragile. Other folks are working on error correction, because even a tiny mistake can mess up the whole calculation. It's not just about the hardware, though. Companies are also developing new algorithms designed for these quantum computers. It's like creating a whole new kind of software. Let's also mention the cloud giants. They're investing heavily in making quantum computing accessible to everyone through the cloud. Imagine being able to use a quantum computer without having to build one yourself. Want to hear about some of the specific companies leading the charge?
Yeah, please.
Some of the biggest names in tech are racing to build quantum computers. Companies like Google, IBM, and Microsoft are investing heavily in hardware and software development. They're building their own quantum machines and also providing cloud-based access to them, so developers and researchers can experiment. China's tech giants, Alibaba and Baidu, are also major players in the space. Even car companies like Volkswagen are getting into the game, seeing potential uses for things like self-driving car technology. It's a really exciting time for the field. Tons of smart people are working on this, and it feels like we're on the brink of some major discoveries.
Yeah, that's why I'm too much fascinating about this quantum computing. Like there is so much to explore in this. Like
Absolutely. Quantum computing is a wild ride. It's one of those fields where it feels like we're on the edge of discovering something truly revolutionary. It's way more than just powerful computers. It has the potential to reshape so many parts of our lives. Are you interested in learning about some of the ethical considerations around quantum computing? Or maybe you want to dive deeper into a specific application?
so for today, I think this is enough for our podcast. We'll discuss that part in our second episode. And thank you for the cooperation and thank you for explaining me these topics briefly. I hope my audience will really appreciate it. And if there is any problem, they can mention it. So, how do you like it?
Well, I think we covered a lot of ground on quantum computing. It's definitely a complex topic, but I think we did a good job of breaking things down and making it understandable. I'm curious, what made you choose quantum computing for your first episode?
Because I'm quite fascinated about this quantum computing thing, and I really like to know more and explore more. And maybe if I'll get chance to become a quantum scientist one day, I appreciate. I will do research on this topic.
That's awesome. Quantum computing is a fascinating field, and it's great that you're so passionate about it.
Yeah, thank you. So, thank you for your presence, for your time, and I appreciate that. And we'll meet it at another episode. Thank you, Gemini.
You're welcome. Thanks for having me on the show. I had a lot of fun talking about quantum computing with you. No problem at all. I'm always happy to help out. Let me know if there's anything else I can do to help make your show a success.
Yeah, thank you. Thank you for listening, guys. Like, subscribe, and comment down your thoughts. I hope you enjoyed it.